Good morning, everyone. We're just about to start, so if you can please take your seats. Thank you. Good morning. Can you hear me well? Yes? Okay, perfect. Good morning. And welcome everybody to the University of Saskatchewan's Engineering 3-Minute Thesis Competition. My name is Emilia Olivares. I'm a second-year master's student in biomedical engineering, and I'm honored today to be your Master of Ceremony. Thank you, AGCC, for the invitation. As we gather here today, both in person and online, we would like to acknowledge the Indigenous people of all the lands that we are joining this event from. For us in person, we are in Treaty 6 territory and the homeland of the Métis. We pay our respect to the First Nations, Métis ancestors, and other Indigenous peoples of this place, and reaffirm our relationship with one another. I would like to ask everyone at this time to please rise for the national anthem. Thanks, EGCC team, for the video. So now I would like to introduce our panel of judges today. I want to make the remark that they're all USACS alumni. First, we have Margaret Kusik, EAT trustee. Christy Miller, Director of Alumni and Donor Engagement and Executive Director of the Alumni Association at the University of Saskatchewan. Dr. Suza Pap, Saskatchewan Representative for MyTax. Dr. Sumit Kahanda, Project Manager at Saskwater and SES President. Dr. Tate Cow, Assistant Professor at the U of S and the Board Chair in Engineering Entrepreneurship. And Dr. Mohsen Shakuri, Staff Scientist and Beamline responsible of the sub-X-ray microcharacterization beamline at CLS. Thank you all for coming. At this time, I would like to invite our Dean, Susan Cresta, to give us a welcoming message.
Thank you. Good morning, everybody. It's awesome to have such a great turnout for this event. We're in a huge room today, so it doesn't look like as many people as it really is. But welcome, everyone. I particularly want to thank our industry partners who are joining us both in person and virtually. It's great to have you here. It's a wonderful opportunity for us to showcase some of the exciting things that are going on in the college. I want to acknowledge that as we gather here today, we stand on the traditional homelands of Treaty 6 territory and the Métis. And I want to remind all of us that when we think about land in an Indigenous space, the land is something that we serve, not something that we own. And so acknowledging the primacy of the land is it's a piece of value system that we're starting to understand better as we grapple with some of the big problems we face today. So it's a useful reminder to have with us at all times. It's a terrific privilege for our college to sponsor this student-run competition. Every year, I think it gets a little bit better and a little bit more pro. And so it's lovely to see it growing in size and growing in strength as we move forward. As engineers, we're always seeking to find ways to build bridges of understanding. And the E3MT competition is all about building those skills in our graduate students, giving them an opportunity to move past the jargon that they've worked so hard to learn and dig into the basic ideas that they're trying to study and convey to the general public, to industry, to job interviewers, and to share on cover letters. And that ability to present clearly and concisely is an important skill for leadership, for building teams, for explaining problems and processes and goals to the people around you. So what we're doing today is a fun sharing of research. The skills that you walk away with will build a career. And so I want to applaud everybody who stepped up and who is going to have the courage to stand in front of their peers and present their work, either here or virtually, because we're all looking forward to hearing what you have to say. I also want to thank the people who made this event happen today. It provides an opportunity to recognize the important relationships between the college and our community. We saw the listing of the gold, silver, and bronze sponsors during that introductory video. And I leaned over and I said to Dr. Zoltan, you know, we never could have done anything like that when we were graduate students. The idea of building a video, that was something that movie producers did. And so it really wasn't on the roadmap for us. Sask Power, the Engineering Advancement Trust, are gold sponsors today. The Saskatoon Engineering Society and the GSA are bronze sponsors, and the college is delighted to join at the silver level. I also want to thank the judges who've taken time out of some really busy schedules to join us today, to hear the stories, to give us perspectives from many different relationships and many different lenses on how this works out. And I know that that feedback and those thoughts, they'll have a tough job at the end of the morning, but what we hear from them is really, really valuable. Finally, a special thank you to the Engineering Graduate Community Council for all of your hard work to organize the event today, and keeping me in the loop as things developed and making sure things were in my calendar so that I could be here and have enough time to stay. So a special thank you for that. We also are hosting the event in a hybrid format. So competitors can get experience presenting to a live audience in person. Audience members can join from all across the country, and I believe we also have some virtual presentations, right? So this is a new way of trying both methods, and it's also a set of new skills that we all need to learn. So a big wish for good luck to all the students who are competing today. I hope that you present at your best and that your story lands nicely. And I'm looking forward to watching and hearing from all of you. Thank you so much.
Thank you, Dean Cressa, for your words. So now I would like to invite our EGCC President, Abbas Fassel, to give us a welcoming message.
Thank you.
So good morning, everyone. Thanks for your coming today to the Engineering 3D Test competition. I would like to give my warm welcome to the judges and all participants in this valuable event. So thanks, Dr. Cresta. You make my job easy. You told everything to the audiences. So I want to give you a very short, report. I would like to thank my all team. They did a lot today. We had lots of organization before the event. I would like to share my thanks to all of the team members of the EGCC. So fortunately, we have around 52% PhD students today for the presentation. Also 47% of the presentations are from the master degree students. So the 63% of the presentations are in person and 36% around is the online presentations. So the chemical and biological department did a very great job today. So we have lots of presentations from this department. Thank you all. So I would like to share my thanks to the sponsors, also the SAS Power and Engineering Advancement Trust. They helped a lot, so we couldn't make it without the support of the sponsors, College of Engineering, Saskatoon Engineering Society, and Graduate Society Association. So thank you all. I hope you enjoyed the event, and thank you, Emily. Back to you. Thank you.
So before we start, I would like to go through the competition rules just to have a fresh reminder. The standardized rules of the 3MT competitions internationally are as follows. Presenters are allowed a single PowerPoint slide, no slide transitions, no animations or movement, and the slide is presented from the beginning and from the duration of the presentation. No additional electronic media are permitted. No additional props are permitted. Presentations are limited to 3-minute maximum. So you'll see this countdown in the middle. That would tell you how the time is running. And once you hit 3, it will 3 minutes. It will say there, and your presentation has to finish by then. Presentations are limited to spoken word, so no poem, raps, or songs. Sorry. Presentations are to commence from the stage, and presentations are considered to have commenced when the presenter starts their presentation through movement or speech. It's a friendly reminder that the decision of the educating panel is final. The first session that we'll have today will be in person. After that, we'll have a 20-minute break, and then we'll listen to the online participants. After all participants have been presenting their work, the judges will deliver it. So without further ado, let's start this competition. Please welcome our first competitor today, Alec Roger Vista.
Good morning, everyone. We're going to be kicking off today by talking about marijuana and engineering. An engineer's high is when we find constant values or a set of standard equations that we need to complete our calculations. It's the best feeling ever, and you probably know these. These are standards or standard equations that we find in book indices, and these values allows for us to design buildings and equipment in a matter of days. Now, think about the cannabis industry that came in 2018. We had the existing knowledge to be able to design and build equipment, but we didn't have standards to optimize our calculations for cannabis. And nobody really took the time to publish these standards for obvious reasons, illegal. But what are the repercussions? Without optimized calculations from the industry working, we found that there were consumer complaints of moisture loss, mold, and degradation. And as engineers, this could have been easily troubleshooted by using two simple parameters in our calculations, temperature and humidity. Compiled with the product's moisture content, these are called standards of sorption isotherms, and isotherms allows us to accurately address moisture-related problems. So what I've done so far is this. I have collected drying data, and I've also collected some physical attributes and like size, volume, and densities, and that was phase 1. In a matter of a week or two, I'm gonna begin phase 2, and that's going to be investigating the equilibrium water content in a combination of temperatures and humidities that pushes cannabis to its extremes, but only enough so that the medicinal and psychoactive properties are preserved. And based on previous studies, this is around 0 to 50 degrees Celsius and about 10 to 80% relative humidity. Phase 3 is going to be publishing these standards, and the dream is we are going to be able to design buildings and equipment optimized for cannabis. As the cannabis industry spreads its wings into medicine and life improvement purposes, we find avenues to use our talents as engineers in the forefront of this emerging industry. In the hallways of the University of Saskatchewan College of Engineering, this is where the story of cannabis begins.
Alec. So now please welcome Amir Nouri. Yes, yes. Sure, sure.
There is no slide.
No, after finishing the job,
Hello, everyone. The demand for protein is going to double to nearly 950 million tons in 2054. The main drivers for this increase are mainly due to population growth and also lifestyle change. People tend to consume more protein in their daily food. But there is a big question here. Are we able to cover this demand only by animal resources? The answer is a big no. Because there are some issues related to water resources and also environment related to animal farms. The same concerns also go to health issues of the meat and also unethical growing and slaughtering the protein. Unethical slaughtering of the animals. Plant protein has emerged to be one of the most reliable substitute for animal protein. But there is a big hindrance for plant protein, and this is the flavor. This is the awful flavor that we have in plant protein. And because of this issue, there are increasing basically demand for animal protein in the world. So what is the solution? The solution is that we have to deflavor it, and the deflavoring is part of our project. Deflavoring by ozone specifically. Because of problems that we have with our flavors, I mean, we have decided to use ozone, that it can oxidize safely most of the flavors. Ozone, on the other hand, has some other characteristics. For example, it can safely decay in a matter of minutes, and so we don't need any expensive separation process. On the other side, we can use it in gas or liquid operations. So basically, we can hit two birds in one stone. And if we can do that by reduced cost, we will be able to show a gorgeous bottom line in the P&L sheet. Prairie has a big resource of water and land, and it's already the biggest exporter of some pulses in the world. And by adopting some value-added processes in the current business environment, in a multidisciplinary approach, we will be able to have a lot to say. And this project is an example. We are expecting a big contribution from Agriculture Department, and we as a team can turn this province and prairie to the world basket of protein. Thank you very much.
Thank you. We'll give the judges a few seconds to work on their. So thank you for your presentation, Amir. Now I would like to invite Arash Yasadeh, please.
Global Earth result has been recently issued regarding global warming. The analysis result shows that the average temperature of the world land rose significantly over the past 250 years. It also shows that by 2037, the average increase reached to 1.5 degrees Celsius, which is a big challenge for our future planet. It means that our planet in future would be warmer and warmer. Good morning, everyone. My topic of presentation today is a conversion of agriculture waste to fuels and chemicals. Global warming because of carbon dioxide emission happened. This carbon dioxide emission leads to climate change, which is the main threat for many species such as polar bears. Chemical engineers try to find a green solution to overcome these obstacles. And the answer is Fischer-Tropsch synthesis technology. As we all know that Canada has lots of agriculture wastes, including wheat and canola. It's about 2.9 million tons per year. This agriculture residue can change to syngas. Syngas is a mixture of carbon monoxide and hydrogen. By introducing this syngas to Fischer-Tropsch reactor, we can produce high-value chemicals and hydrocarbons. As you can see in the center of the slide, the main part of the Fischer-Tropsch synthesis reactor is designing catalyst. Catalyst is a substance facilitate the procedure of the syngas which reach to the surface of the catalyst to high-value chemicals and hydrocarbons such as light olefins. Light olefins, including ethylene and propylene, are key building blocks in petrochemical industry. These light olefins can produce for valuable materials such as paints, rubber, plastic, and fibers. In the current state, the beneficial of using Fischer-Tropsch synthesis compared to fossil fuel methods is just $321 per million ton. Our focus of research try to develop an efficient nanostructural catalyst to enhance the productivity of the Fischer-Tropsch synthesis. Because of using agriculture waste, Fischer-Tropsch synthesis is a carbon dioxide neutral procedure, which means reduction of greenhouse emission and at the same time prevent environmental collapse. Thank you so much for your attention.
Thank you, Arash. We'll give a few seconds to the judges to deliberate. Please welcome Christopher Elash.
Yeah. Okay, so we live in a digital world, and much of our important information is now stored and processed using computers, which is great because we enjoy a variety of benefits that they provide every single day. But our computers are under attack by an invisible enemy, and that enemy is actually radioactive particles. You see, every day we come into contact with a variety of these particles, a lot of them originating from space, where a highly energized particle can come and hit our atmosphere and shatter into a multitude of different particles that then rain down on the ground. Now, for me and you, this is really no big deal. It's nothing to be concerned about. But if you're a small transistor on a computer chip, these particles can actually cause quite a bit of problems. We store information using bits in computers, and the change in one bit caused by one of these radioactive particles can drastically change the value that's being stored or the calculation being performed. And there's actually a well-documented case in Belgium where an electronic voting machine was struck by one of these particles and one candidate received many more votes than they really should have had. So if these particles can potentially sway the results of elections or impact other critical pieces of infrastructure, then something really ought to be done. And so what can we do? Well, I think the logical thing and the first thing a lot of people think of is that we should protect our electronics and put some sort of shielding around them. And it's a good idea, but this is really impractical. Some of these particles have such a high amount of energy that the amount of shielding we would need to protect them would just be unreasonable, especially while we want to keep our phones and laptops as compact as possible. So what can we do? Well, instead we adopt radiation hardening techniques, which is really the crux of my research, is finding new and innovative ways to protect our electronics without sacrificing their performance. So I like to put these into two subcamps. The first is structural hardening, where we actually change the layout and the placement of the transistors on our chips in such a way to mitigate the effects caused by these particles. And the other method is logical hardening, where instead of changing the layout of the chip, instead we change the flow of information through it. So for an example, we could run a function or a calculation 3 separate times and then compare the results in the end to make sure that they match. And if one doesn't, since it was affected by a particle, we can use the other two values and we can keep going as if nothing happened. So by combining these two techniques, we eventually can end up with a radiation-hardened computer chip or computer core. In the past, these have mainly been limited to space and defense applications, but nowadays, because our transistors are so small in consumer electronics, the susceptibility to these particles actually increases every single year. So by furthering this research and finding these new ways to protect our electronics, hopefully in the future, we can better defend against this invisible enemy. Thank you.
Thank you. Like to invite Priyanka Tirumaredi to the stage, please.
Good morning, everyone. Today, I'm going to talk about sustainability. What is sustainability? A sustainable society is one where we do not damage the environment or overuse the resources so that our future generations will live comfortably. How is this related to energy? Currently, we are living very comfortable lives because we have continuous supply of energy. We are driving to work, we have electricity, we are cooking food, and we have industries running. All this energy demand is met by the use of fossil fuels like petrol, coal, and natural gas. So how are these fossil fuels formed? Millions of years ago, dead plants and animals were decayed under the earth, and under the high temperatures and pressures are subjected to form these fossil fuels. But there are very limited resources. If we go on use these fossil resources without finding a sustainable alternative, our future generations will be deprived of energy. So the production of fuels from agricultural residues is considered as a most sustainable alternative. We all know Canada is very rich in agriculture. It is the world's largest producer of canola and mustard seeds. It produces around 20 million tons of canola and 2 lakh tons of mustard every year on an average. And more than 50% of it comes from Saskatchewan. How fossil fuels are formed, they are subjected to high temperatures and pressures. So we are replicating that conditions in the reactor, and so these agricultural residues are thermally decomposing into bio oil and solid residue biochar. But this bio oil cannot be directly used in our automobile engines because they have very high concentrations of oxygen and nitrogen, which makes them very viscous, and they will become hard solids at high temperatures. So they need to be treated. But fossil fuels do not have oxygen and nitrogen because the solid mud will absorb them, and rocks acts as catalyst to absorb the oxygen and nitrogen. So therefore, we are using the same concept of adsorption here. We are preparing a catalyst using the biochar obtained from the process. It have very high, excellent adsorptive properties, and we add active metals like nickel and molybdenum, which can easily attract oxygen and nitrogen, so that these compounds can be removed easily, and the upgraded bio oil can be sent to the refinery, where it can be co-processed along with the crude oil to generate petrol and diesel range fuels. So this is how we maintain the sustainability and give back to the community. Thank you.
I'd like to invite Hamed Alizadeh Sarrout to the stage, please.
Hello, everyone. My name is Hamed. I'm an engineer, and I do science to treat osteoarthritis. Osteoarthritis is a highly disabling disease by which, excuse me, I think there's a problem with my slide. Some pictures are missing. Yeah, this is not the one that I sent, but can I start from the beginning? But yeah, there are some pictures missing anyways. So yeah, I have to start from the beginning. So my name is Hamed. I'm an engineer, and I do science to treat osteoarthritis. Osteoarthritis is a highly disabling disease by which the cartilage in the joints, especially in the knee joints, begins to break down. It causes stiffness, pain, and also swelling. In some cases, in some cases, it also causes reduced function and disability. Some people are no longer able to do their daily tasks and work. Within the next 30 years, over 13 million Canadians will be affected by osteoarthritis, and the direct cost of osteoarthritis is projected to increase from $2.9 billion to $7.6 billion. clinical treatments that are available right now are not very successful today, successful because they don't result in long-term correction of the cartilage. So here, cartilage tissue engineering comes to play a role. And it aims to replace the damaged cartilage with a biomanufactured replaced tissue. So cartilage tissue engineering incorporates three main components: biocompatible scaffold, live cells, and bioactive molecules. So cells consume those bioactive molecules inside the scaffold and regenerate the cartilage matrix. Cells actually normally can generate different kind of molecules by responding to their chemical and mechanical environment. And the hydrogel are one of those most favorable scaffolds that have been used very widely for cartilage regeneration. These hydrogels are very soft. They are friendly. They are chemically friendly for the cells. However, they have very low mechanical properties. So when we put the cells inside them, when a force is applied on the scaffold, this force can be easily transmitted to the inner environment of the scaffold, and the cells will sense the force. And unfortunately, actually, the cells don't like the force. They don't want to push them to generate the cartilage. So when we implant them in the joint and there's a force from the body weight on them, the cells sense those forces and generate some molecules that are not good for cartilage regeneration. So hydrogels fail to generate the articular cartilage. Our solution is using a 3D bioprinter to fabricate hybrid 3D bioprinted constructs and implant them in the joints. These scaffolds are composed of two kinds of strands from two different materials. One is PCL strands that are stiff and hard. You can see them in red color in the picture. And these strands are larger than the other kind, which is a hydrogel and have cells inside them. So the smaller hydrogel strands have the cells. And when we implant these scaffolds in the joint, the larger PCL strands can actually shield the hydrogel strands, which are smaller, from the applied force. So the cells don't feel the force and generate the molecules that we want for articular cartilage regeneration. So we hope that in near future, we use these bioprinters to fabricate hybrid scaffolds, implant them in the joints, and treat the osteoarthritis. Yeah, thanks for your listening.
Thank you, Hamid. So I would like to invite Li Shu to the stage, please.
Good morning, everyone. Vegetable oils, together with sugars and proteins, provide energy for our daily activities. Also, they good carry for the vitamins, micronutrients, which are good for our health. Besides, they provide us essential fatty acids that cannot be generated by our body. Therefore, vegetable oils are very important for human beings. Typically, vegetable oils come from vegetable seeds, for example, canola seeds, soybean. When the oils are extracted from the seeds, they are dirty. They contain various types of contaminants. And those contaminants are usually associated with unacceptable oil quantity issues, such as the bad smell, the terrible appearance, the oxidative stability issue. So the contaminants must be removed from the oils. And this process is called oil refining. A typical vegetable oil refining strategies involve multiple separations. Those processes are energy intensive and the substantial oil loss can happen in the process. The shortcomings of the older methods have motivated people looking for new methods. Electrostatic field treatment is one of them. This method has been successfully applied for the purification of some dirty industrial oils, for example, lubricating oil, hydrantic oil, by removing some polymer compounds from these dielectric fluids. And then this process is achieved based on the principle named electrophoresis, in which the polymer compounds will move towards the electrodes and finally will be attached to the electrodes under the force of the electrostatic field. Then the contaminants are removed from the oils. Vegetable oils are also a type of dielectric fluids. However, some compounds, including phospholipids, free fatty acids, peroxides, are polar contaminants. So electrostatic field treatment could also be applied for the refining of the dirty crude vegetable oils. When the dirty oils pass through the field, those polar compounds will finally be attached to the dielectric medium. Then we can get clean vegetable oils. So altogether, electrostatic field treatment could be used as an alternate for the conventional vegetable oil refining strategies in a more economic and environmentally friendly way, as it consumes less energy, requires no chemicals, and generate little waste. Thank you.
Thank you. I'd like to invite Tumpa Sarkar to the stage, please.
Hello everyone, good morning. Today feels like -26 and this week weather was pretty cold and we are still surviving just due to the internal heating. Any idea what is the source of the heating? Yes, you are right. The fossil fuel is the supplier for the for heating, and dependency on fossil fuel is increasing rapidly due to rapid industrialization and population growth. As we all are dependent on energy and we are extensively uses the fossil fuel, and which causes climate changes, carbon dioxide emission, ozone layer depletion, environmental pollution, global warming, and so on. Now, the question is, how can we save the world and meet up the energy demand of this growing population? The answer is look for alternative energy sources. There are a lot of researches going on to find out a sustainable sources for energy that can replace the fossil fuel. And bioenergy is one of them. Here in Saskatchewan, as an agricultural province, we are producing a lot of agricultural residue. And you all know about the cannula. On an average, every year in Saskatchewan, we are producing 5.9 million metric ton of cannula. After processing of cannula seeds, around 10 to 15% is just waste or residue. And there is no application of this residue except landfilling or burning or just direct disposing, which also causes climate changes, environmental pollution, and groundwater contamination. So what is the solution? My research comes with the solution. So we are trying to develop a sustainable way to convert this waste into oil. How? I'm taking this cannula residue, heating it up under nitrogen to remove the moisture, and then compress it to produce fuel pellet. And it has all those properties like coal. It has high energy content, it is durable, it has high strength to transport and store. It is easy to handle, and major advantages of it is low emission, net carbon emission is 0, and low cost. So therefore, production of fuel pellet from cannula residue can be a sustainable approach to replace fossil fuel and contribute to the national economy. So I would like to invite you to contribute in the world. No more emission, use green energy, save the world. Thank you.
Please welcome Mohie Aldine Shaban to the stage.
Talking about the behavior of fluids, fluids fall under three main categories: Newtonian fluid, shear thinning non-Newtonian fluid, and shear thickening non-Newtonian fluid. The Newtonian fluid has a constant viscosity that is independent on stress. Water is an example of Newtonian fluid. The viscosity of shear thinning non-Newtonian fluid decreases with increasing shear stress. They are the most common type, and examples can easily be found in daily life, like paint, or from food industry, for example, yogurt or ketchup. Ketchup, for example, exhibits shear thinning non-Newtonian fluid due to its additives such as xanthan gum. It allows the consumer to squeeze the ketchup out of the bottle, but once you release your hand, the ketchup, the viscosity of ketchup increases again and prevents it from flowing all over the dish. Some do due to poor qualities. The opposite effects are the shear thickening fluids. The viscosity of shear thickening fluid increases with increasing shear stress. A good example of that is the cornstarch water solution. It's well known in social media by walking on water, non-Newtonian fluid. So if you want to have fun, you can just fill a swimming pool with this suspension, and then you can run across the surface. You can run across the surface, but if done quickly. If you just stand on it with no pressure, you sink. So going back to my research, I studied the behavior of nickel lateral slurries. Results show that nickel lateral slurries behave like Newtonian fluid at solids concentration below 43.8%, and exhibits shear thinning non-Newtonian behavior at solids concentration above 43.8%. Also, results showed that adding fine particles to slurry prepared from coarse particles reduced the magnitude of non-Newtonian behavior. You may ask, what are the benefits of those discoveries in mineral processing? Well, knowing that slurry behavior plays an important role in transportation, filtration, classification, and determination of leaching conditions, such as temperature, pulp density, and slurry pretreatment. For example, in industrial mixing application, it's reported that the shear forces on the surface of the tank are very low, causing the slurry to agglomerate and causing stationary mats. This is so problematic for mixing efficiency. So knowing the behavior of those, knowing the shear thinning behavior, will allow us to improve the mixing and avoid all those challenges. Thank you.
I would like to invite Olivia Mukherjee to the stage, please.
A couple of years ago, if any one of you have told me that a cup of coffee can control climate change, I would have simply nodded my head. However, through this presentation, that can caffeine contribute towards climate change, yes or no, in less than 3 minutes, we all are going to find our answers. Now, imagine yourself in a crystal clear surrounding. You see birds, fresh water, vibrant color, trees. You just exactly know life thrives in and around the surrounding. Unfortunately, this figure further gets away and away from the actual reality. We humans have created excessive amount of carbon dioxide. The major consequences are in front of us. It's the rise in temperature, decreasing rainfall, and what's scary is it causes global warming or hashtag climate change. Now there's another problem that we all are less aware of, and that's coffee. Don't worry, it's still going to be everyone's favorite hot beverage. And why not? If it's minus 10 degrees Celsius outside, you would definitely need your favorite cup of latte. However, due to this tremendous popularity, availability, the consumption is high, which is giving rise to the waste called spent coffee grounds. It's in million tons generated each year in Canada, just simply discarded in landfills. What if I told you that there's a way to utilize the spent coffee grounds to capture carbon dioxide? Well, the process or the approach that I'm using to formulate the spent coffee grounds to produce activated carbon is called valorization. The methodology is simple, but you might be thinking, is it really possible? The answer is yes. Activated carbon, when produced from spent coffee grounds, contains two important or major factors to capture carbon dioxide. One is space. Huge space will always accommodate thousands and thousands of carbon dioxide molecules. And the other theory that works is opposite attracts. The surface chemistry also plays a significant role here. So these days, through my research, I have proposed a strategy, a carbon negative strategy that is compatible with the commercial technology available in the market. These days, while sipping my favorite cup of latte or mocha, I do not worry about the existence of planet B. And you know why? Because the answer is yes, spent coffee grounds or caffeine can really contribute towards climate change. Thank you so much.
Thank you. So for this next competitor, unfortunately, he didn't make it today. So we'll go to the next one. So Ahmad Karimi is not coming today. So please invite Julio Torres Tello to the stage, please.
Well, good morning, everyone. I know we have been going through many presentations this morning, so I will try to be quick, about 3 minutes, I hope. So I'm going to tell you a little bit about what I have been doing these last 3 years at the University of Saskatchewan for my PhD project. So when I just came here, it was a matter of choosing some topic. You have probably heard about machine learning, deep learning, artificial intelligence, and a lot of applications, mainly in natural language, what is making possible to translate documents, for example, or exploring images. You know, when you go to Google and you can Google an image, for example, that's pretty neat. But I didn't really like these mainstream applications. Considering that Saskatchewan has a very strong agricultural sector, I tried to go a little bit into that field. It wasn't that difficult to find projects in which you can apply this kind of new technologies that are like everywhere now, even in industry or collaborations with another departments at the university. So I tried to get some kind of information from remote sensing, for example, images from drones. And I was also trying to get information from sensors, for example, for aeroponics crops. I don't know if you know these new technologies that grow just with air and water and nutrients and this kind of stuff. So you can get a lot of information from there, and you can train these models basically to try to predict how well they behave if you put more nutrients or you give them more light or things like that. And my main focus was to try to optimize these models so they wouldn't be so heavy, so computationally intensive, so that in the end you could actually put them into small computers. You could load these models and these computing devices into drones, for example. So for that, I was mainly focusing on trying to choose which features are like the most important for the machine to make a selection. This is a very active research field nowadays, like trying to explain why a model is making such decisions, because people usually say that we feed the computers with information, but then you don't know what the computer is using to make a decision. So I was trying to implement this kind of models with different kinds of technologies. And actually, I have found that it is possible to find features using different techniques. And you can actually implement these models in small computers, like let's say the size of a credit card or so on, so that you could implement these models in robots or drones, for example. So basically, that's what I have been doing and what I wanted to tell you today. I have been doing that for the last 3 years, like besides trying to survive the pandemic, that has been my main focus these years. Thank you.
Now I would like to invite Sana Danesha Moose to the stage, please.
Hello, everyone. Why and how we get to this critical point of climate change for the Earth? And how did you feel last summer when you walk out of your house and saw the smoky sky. I know everyone here knows what is the effect of climate change. The most recent one was what happened in BC last year. The heat wave shattered the temperature record, and around 600 people died. 1 billion animals were baked in that temperature. So, I think our previous action during past decade let global warming happen, mainly because of using fossil fuels. And now it's time to make some changes in our way of living, the way how we use energy. My research is focused on using a kind of biomass called canola dockage as an alternative solution to replace fossil fuels. So everyone knows what is canola because Canada is one of the major sources of producing canola oil. So when harvesting canola flour, what the seed goes for producing oil. Whatever is remain is called canola dockage. But we cannot use this canola dockage directly to produce energy. We need some action, meaning that some action should be taken. We call this action pretreatment. And torrefaction is a kind of common, like a thermal pretreatment that can convert this canola dockage to biochar to be used in power stations. So I think it's time to put one step forward. The world we live in is the result of the reaction we made yesterday. And the world we will live in tomorrow will depend on our decision today. Thank you very much.
I'd like to invite Mohamed Reza Begjoe to the stage, please.
Yeah. Hi, everyone. Thanks for having me here today. Today, I'm going to talk about a new idea that would definitely affect oil and gas industry. Canada and the US are placed among top 5 countries in the world in natural gas production in 2020, according to International Energy Agency. Crude natural gas from gas well contain high amount of water, so it's not possible to use it directly in downstream processes because of two major problems. First, it has low heating value, and second, water could cause forming hydrates inside pipelines when transferring natural gas in distribution network. So, water should be removed from natural gas. As a result, some technologies have been proposed for this purpose. The most conventional one is adsorption in adsorption column. Some commercial adsorbents that have been used inside the column are silica gels, activated alumina, and molecular sieves. These materials are good, but there are still two major concerns. First, these materials are expensive, and second, they need high energy to be regenerated after adsorbing water. Our group developed a new idea to use agriculture byproducts as adsorbents because of their inherent characterization and properties. Saskatchewan, based on Canadian government, is one of the largest producer of crops, with an increasing trend since 1980. So, a huge amount of agriculture byproducts have been produced in the province, and we need to consider it, and we need to take advantages of them. We choose canola meal and oat hull as our fresh material, and then we use a lab-scale pelletizer to increase and enhance their quality. We produce numbers of pellets, and by using optimization techniques, we propose four main pelletized biosorbents. Our materials are perfect because they have high density and strength, so it will reduce cost of handling, transportation, and storage. Next, we test our material in an environmental chamber to see their adsorption capacity, and the results were brilliant because their adsorption capacity was in the range of commercial adsorbents, or even higher than some of them. Our last step is to test this material in a pilot scale adsorption column to see their performance in a situation similar to the real industry. We achieved two main goals. First, we reuse the waste material, which is beneficial to the environment and also to our local community. And also, we reduce the amount of energy. Thank you very much.
So for this next participant, she wasn't able to come. So Sarah Alab Moradi wasn't able to come. And I will please invite Zima Zainali Danalu to the stage.
Yeah. Hello, everyone. My name is Sima. I started my graduate studies during COVID, and today I'm super happy to be here to talk about my research and why you should care about my research. Pharmaceutical is one of the key factories or industries having impact on the health and the quality of life. There are some concerns there, and today I will discuss about a method very good to meet the standards and solve the problems there. There are three main factors and properties that the granules or the tablets should have. Very exact amount of the drug content or dosage, sufficient strength to avoid damage, also at the same time, good dissolution rate and drug release behavior. What would be one of the main factors affecting these properties? Granules pores. So, good quality tablets or granules form from the good formation procedures. And there should be a way to look at the procedure internally. For sure, we cannot see it with our eyes, even not with conventional methods. Synchrotron X-ray has 10 to 6 times higher energy flux compared to conventional methods. What does it mean? It means that it can capture real-time, very fast procedures taking place in seconds, even milliseconds, but at the same time, keeping the good resolution. Also, it can be tailored to the sample's nature. All around the world, there are just 25 countries having synchrotron light sources. And you can find them on red dots on the map. And today I want to express that how proud I am that for the first time I'm using this technique to study the 3D view of the wet dynamic granulation at Canadian Light Source in Saskatoon. You can see my photo there. I was doing some research like experiments based on the single droplet impact method to see the wet dynamic granulation. So by having this technique, we could be able to see the pores distribution, also drug distribution in the pharmaceutical static powder, also 2D view of the penetration in milliseconds, and the pore evolution inside the granule during seconds. So what would be the result? By having this technique, we could be able to optimize the materials and methods for the larger scale in pharmaceutical industry. And I believe that every industry, not only pharmaceutical, like food science, agriculture, could benefit from this technique to have a better idea of the internal structure. Thank you very much.
Now I would like to invite Tuan Truong to the stage, please.
In January 2009, a U.S. Airways Flight 1549 took off from the U.S. Airways Flight at the U.S. airport, LaGuardia Airport at 3:25 p.m. 2 minutes after takeoff, the plane was struck by a flock of birds. Upon realizing that the plane had lost all engine power and is far to reach any airport in time, the pilot in command at that time, Chesley Sullenberger, decided to land the plane on the Hudson River. Yes, on a river, saving the lives of everyone on board. The incident came to be known as a miracle on the Hudson. Well, you can imagine that a bird colliding a plane at very high velocity and boom, and it is not uncommon. A survey found out that airlines face an average of 34 bird strikes in a day. Wow. So how could we prevent the failure? Well, we may kill all the birds, right? Yeah, no. May all the environmentalists kill me first. So it seemed not feasible. So how about we improve the failure resistance of the airplane? Failure resistant? Well, that's just a buzzword. So let me put it this way. How about we create a material that can withstand an impact at very high velocity? And more importantly, because of the high frequency of the incidents, the material has to be fast manufacturable and customizable. And that's when 3D printing comes into play. So instead of molding a machine in a part, 3D printing can fuse a material to deposit one layer at a time to build up a part. So it's faster, it's lighter, it's fashionable, it's really a game changing. So in my research, I use 3D printing to fabricate different margin steel, which is a material having a ridiculously high strength, and subjected them to the high velocity impact test. So we found out that when depositing one layer on another one, the material consists of a number of little teeny tiny holes, which are called as pores. So as long as we minimize these pores, the material becomes stronger. So the less number of pores, the higher failure resistance of the material is. So before ending this presentation, let me leave you with this question. What if the plane was hit at different location? And what if the pilot in command at that time was not Chesley Sullenberger? That's when 3D printing materials come into play. Thank you.
Now, please welcome Mohammad Amin Zamiri to the stage, please.
Hello, everyone. Today, I'm going to talk about microwave-assisted production of porous carbon materials, or activated carbons. Okay, when you look at the activated carbons, it's a black powder, but I think you are going to get surprised if you know that there are a lot of tiny pores inside its structure. So it has a huge surface area. 1 gram of it can have from 500 to 1500 cubic meters of surface area, an area as large as area of a farm. So there are a lot of available sites to attract contaminants, and is a potential material to be applied as filters for water contaminants and air pollutants. But how is activated carbon produced? If you actually treat agricultural residues with acids or bases and put them under a thermal treatment, then you can have porous activated carbons. Conventionally, an oil bath or a furnace can be used as heating sources to produce porous carbon materials. But the problem is that it takes a very long time to produce activated carbons, from several hours to sometimes more than a day. To solve the problem, it's possible to use another technology: microwave assisted heating instead of conventional heating. Let's see how microwave works. It may amaze you to know that invention of microwave ovens was accidental. The scientist Percy Spencer was performing an experiment on a device called magnetron, which generates microwave radiation. He observed that during the experiment, the chocolate bar in his pocket got melted. And then he explored application of a microwave in cooking the food. So if you place an agricultural residue inside a microwave instead of a pizza, then you can have high surface area activated carbon or porous carbon material. In fact, the food or activated or the agricultural residue absorbs microwave radiation and heats up. So microwave heating is a very fast method of heating, and I think it almost looks like a magic. Thank you so much for your attention.
Thank you. Now, please welcome Amin Babai Hasvini to the stage.
Hello, everyone. Sustainability, biodegradability, plastic waste, and electronic waste. These are some hot keywords that we can see in the media and literature nowadays. But when it comes to advanced functional materials, there are lots of twists here. For example, a simple humidity sensor. Is it possible to make it out of some biodegradable material? Imagine a bio-based humidity sensor that we can stick it into food packaging and see how fresh the food is. However, this is not the only application for such a fantastic sensor. Cellulose is the most abundant biomaterial on Earth that we can see in the figure, extraction figure, top left. We can extract cellulose from biomass. But we also can extract cellulose nanocrystals, or CNCs, from cellulose. These cellulose nanocrystals have some fascinating properties, such as thermal, mechanical, and photonic properties. Yes, photonic properties. In the center figure, we can see that a regular prism, how it can fractionate white light to its color components. Since cellulose nanocrystals are crystals, they have specific order, we can consider them as nano-sized prisms. So if we give them a specific order and specific structure, we can fabricate our own bioprism. What I did in my research is, once I extracted my CNCs after some modification, I coated them on some surfaces. After some controlled evaporation, they formed some helixes that we can see in the figure top right, helix formation. Theoretically, that helix is the heart of the sensor. According to that equation, when the pitch of the helix changes, we would be able to see different colors from that structure. We can see incoming light and reflected light, which is completely based on reflection. There is no pigments. So if we change the thickness or pitch or the thickness of the coded sensors in situ, let's say by exposing them to different humidity levels, we would be able to change the thickness of those films. They swell, that we can see in the figure. They swell, and the thickness of the helix would be changed. We can see how water molecules can penetrate in between those nanocrystals and change the reflection or the colors. And the result of my sensor, we can see in the last figure, in different humidity levels, 20%, 33, up to 75%, we can see different reflection colors, from blue, aqua blue, green, and red. These are completely structural colors, and this is what I can say advanced functional biomaterial. Thank you.
Would like to invite Behzad Saed to the stage, please.
Hi, everyone. today I would like to talk about three main resources of our lives: water, energy, and food, or WEF. So because of the importance of these resources, different departments have been created to manage them by setting some policies. However, such policies sometimes do not align because these resources influence each other. For example, imagine in Canada, water agency may inform there is no more water available for irrigation, while agriculture agency have planned to double food production. Additionally, energy agency wants to develop new biofuel plantations to deliver lower emissions transport fuel, which again in turn needs more water. On the other hand, IRCC invites more people to come to Canada, and population growth means putting more pressure on WEF resources. At the same time, the country may face with climate change, meaning that there is uncertainty about available water in future. So probably you got the point, what is the problem? These conflicting policies, including uncertainties, helps us with understanding the necessity of joining up the plans that are supposed to be set between these agencies, governments, or policymakers. So nexus thinking approach with the more explicit scope of integration comes to the debate to help us with greater policy coherence by focusing on the interactions between these water, energy, and food sectors. Some examples of these interactions might be hydropower plants, biofuel plantations, irrigation systems, and so on. In addition, in Canadian prairie provinces, water is sharing through transboundary rivers between Alberta, Saskatchewan, and Manitoba, meaning that the way that Alberta manage water will affect the available water in Saskatchewan and Manitoba and downstream. Also, this region is so important regarding farmlands because it has the contribution of more than 85% of Canada's farmland, which is so huge contribution. So what we did in our project in University of Saskatchewan, we used that nexus thinking to identify, quantify, and measure these interactions between water, energy, and food sectors. And why this helps? This helps policymakers to know what are the key factors, what are the key components of our system to invest in to improve the efficiency of whole system, like considering the prairies as one single region to improve the efficiency in terms of web security and economic gain. Thank you.
I would like to invite Shahab Minaei to the stage now, please.
Hello, everyone. We can last weeks without food, but only few days without water. So what happens when this water becomes too contaminated to drink? Currently, a huge issue facing our freshwater resources is contamination by pollutants. So where do all these contaminants come from? I want to take you all to your washroom. Imagine that you are standing in your washroom and taking in its old glory. Now I want to think about those little bottles on your countertop, or the cleaning products under your sink, and the drugs in your cabinet. Once we are done with these chemicals, we usually flush them down. And for most people, that's where the story ends. But as a chemical engineer specializing in wastewater treatment plant, that's just where the story begins. These chemicals, all these products contain chemicals that are referred as chemicals of emerging concern or emerging pollutants, given that they are new and there are lots of environmental concerns regarding their emission. I want to take you to travel with these chemicals into the sewage system. After the water exits our homes, it travels into the sewer system and combines with the waters from thousands of other homes and industries. All these waters are directed into a centralized treatment facility, which lots of different steps are being done to decontaminate these waters before being released into the river. These chemicals, depending on their physiochemical properties in the wastewater treatment plant, could be sorbed to the could be vaporized into the atmosphere, they could be sorbed to the sludge in the wastewater, or they could be digested by hungry bacteria in the wastewater treatment plant. Otherwise, they are leaving the treatment plant unchanged, which is a big environmental disaster. So what could we do? In my research, I'm trying to create a model that could map these emerging pollutants through the treatment facilities. This model helps wastewater treatment plant engineers to have an idea that how much of these emerging pollutants are vaporized, how much is sorbed to the sludge, or how much is digested, and also gives them an idea that how much is being released into the river. So that they could they could change the operational parameters of the wastewater treatment plant to get the highest possible removal efficiency toward removing these chemicals before being released into the river. Additionally, decision makers also could have an idea of how much of these pollutants being released into the river. Because we all deserve clean water, and we should be relieved that the water that we are drinking is safe. Thank you so much.
So due to some technical difficulties with Hamed's presentation, we would actually like to give a second chance to him to present because the slides, one of the images didn't go through. So we're going to give him a second chance to present his thesis. Please come to the stage, Hamed.
Yes. So, yeah, the technical problems. Oh, yeah. Thanks. Yeah. So there it is. Here I am again. So hello, everyone. My name is Hamed. I'm an engineer, and I do science to treat osteoarthritis. Osteoarthritis is a highly disabling disease by which the cartilage in the joints, especially in the knee joints, breaks down, and it causes pain, swelling, and stiffness. In some cases, it also causes reduced function and disability. Some people are no longer able to do their daily tasks and work. Within the next 30 years, over 13 million Canadians will be affected by osteoarthritis, and the direct cost of this disease is projected to increase from $2.9 billion to $7.6 billion. Clinical treatments that are available right now are not very successful since they don't result in long-term correction of cartilage. So here, the cartilage tissue engineering comes to play a role and aims to replace the damaged cartilage with a biomanufactured replacement tissue. Cartilage tissue engineering has three main components: biocompatible scaffold, live cells, and bioactive molecules. So cells inside the scaffolds consume those bioactive molecules and regenerate the cartilage matrix. The cells normally can generate different kinds of molecules responding to their chemical and mechanical properties. Hydrogel-based scaffolds are very popular for cartilage regeneration since they are chemically very friendly for the cells. However, they are soft and they have very low mechanical properties. So when you put the cells inside them and implant them in the joint, the force being applied from the body weight can be sensed by the cells inside the hydrogels. And the hydrogels, unfortunately, they don't like force. They don't want us to push them to generate the cartilage. So when there is a force on them, they generate some molecules that are not really good for cartilage regeneration, and some other type of tissues are produced. Here, our solution is using a 3D bioprinter and fabricate 3D bioprinted hybrid constructs that are composed of two different strands from two different materials. One is PCL strands. They are very stiff and hard, and they are larger than the other type of the strands, which are the hydrogel strands. The hydrogel strands, as you can see in this picture, are in blue color. They are smaller than the PCL, and they have the cells inside them. So when you implant them in the joint and you apply force on them, actually the PCL strands, which are larger, can shield the hydrogel strands from the applied force. So the cells don't sense any force on them, and they generate the molecules that we really want for cartilage regeneration. So by that, we hope that in near future, we can use the 3D bioprinters to fabricate the hybrid constructs, implant them in the people's joints, and generate the articular cartilage, and hopefully treat this disorder, the osteoarthritis. By saying that, this is the closing of my talk, and thanks again for listening to my presentation.
So I would like to thank everyone for their amazing presentations. This wraps up the first session of today's competition. We're going to take a 30-minute break. We have coffee, tea, and snacks by the door. Please avoid eating in the hallways. If you can, there's a lounge by the entrance in health science. So if you can eat your snacks in there, will be appreciated. And we'll see you here at 12:30. Thank you. Welcome back, everyone. So please take a minute to sit down. We're going to start with the online competition. Welcome back. I hope you had a nice break. Now we're going to go through the online session. All participants are live. They're in the Zoom meeting and they'll unmute themselves and do their presentation, just as if they were here in person. Okay. So Zachary Lang is next. Are you ready?
Yeah, I'm ready.
Let me change. Zachary, once you start talking, I'll start the counter.
Okay. A diamond is forever. This famous phrase was coined by advertisers in 1947. It was so popular that it established diamonds as a modern symbol for wealth, power, love, and marriage. It's no surprise that diamonds are valued so highly. Diamond concentration in mines are measured in parts per million. That's grams per ton. In fact, in order to get a typical diamond found in an engagement ring, an average of 2.5 tons of rock needs to be mined. And even then, there's no guarantee that a diamond will be recovered. Canada is one of the leading producers of diamonds in the world. Canadian diamonds are attractive to consumers because they're ethically sourced and conflict-free. Additionally, the Canadian diamond mining industry supports Canada's economy and local communities. Unfortunately, in recent years, the Canadian diamond mining industry has started to decline, primarily due to remote locations and geological challenges specific to Canadian diamond mines. We cannot change the location of the mines, but we can adapt to the challenges presented by the geology. My research aims to validate technology that will address this problem by recovering diamonds more reliably, more economically, and more sustainably. The image in the top middle section of my slide demonstrates how diamond sorting machines function. They detect diamonds and separate them from mined rock. The first diamond sorter, developed in the 1960s, separated particles by exposing mined rock to X-rays and then separating out the diamonds when they lit up from X-ray exposure. However, as seen in the image in the bottom right-hand corner of my slide, There are drawbacks to this technology, as some diamonds do not light up when exposed to X-rays and therefore are not recovered. Recently, another type of diamond sorter has become viable in diamond mining. This sorter exposes diamonds and rocks to X-rays and measures how much the X-rays are absorbed. This allows the machine to determine the element of each particle by evaluating the intensity of the signal as seen in the image in the bottom left-hand corner of the slide. So if the machine sees a particle containing carbon, the element that comprises diamonds, it will separate that particle out. That being said, the ability of this technology to sort small particles needs to be validated, and its effectiveness has not been compared comprehensively to light-based sorting technology. My research aimed to fill this gap. Diamonds exist on a spectrum of size, color, and transparency. To evaluate diamond sorting performance, I measured each of these characteristics, then measured the light response and elemental composition response in each diamond. As expected, light response varied inconsistently between diamonds. However, the elemental response, the strategy used by new, novel technology, was consistent and predictable. This means that diamond sorting using elemental response could recover more diamonds and better adapt to the challenges associated with Canadian diamond mining. Diamonds will last forever, and with the proper technology, the Canadian diamond mining industry may last the test of time as well. Thank you.
Thank you, Zachary. So while the judges deliberate, please Peshmans of Zolfagari Didani, can you turn on your camera? Peshman, are you ready?
Hi, can you hear me?
Okay, you can start now.
Okay. Hello, everyone. I'm confident that you already know about COVID-19 and the fact that its main transmission route is the airborne transmission. In this method, viral droplets containing the SARS-CoV-2 viruses are released to the air from the infected person, and these droplets can travel in the air for even several meters to find their victims. We spend around 90% of our time in indoor spaces, where it is reported that the chance of airborne transmission is almost 20 times higher than the outdoor spaces, and the viral droplets can stay in the air for a much longer duration. So several organizations asked for proper ventilation in indoor spaces and bringing fresh air by opening windows or through the air conditioning system. But I'm highly confident that you are not willing to do so in winter or summer. So the ventilation systems, due to the restriction of the financial resources, are mostly operated in the recirculation mode and help spread the viral droplets throughout the building. Now we know that even isolating at home is not a safe option against COVID. Scientists tried to solve this issue by installing disinfection systems to remove or eliminate viruses in the recirculating air. but most of the disinfection approaches prove to be ineffective or sometimes expensive. A popular alternative is the ozone disinfection method, which is known for more than a century and proved to be cheap and highly effective. If you can add ozone gas to the recirculating air and give it a couple of minutes, it can kill the viruses easily. However, there is a small issue associated with this method, just a small one. If COVID-19 can kill some people, ozone can definitely kill everyone in the building in less than a couple of hours, and it is more dangerous than the COVID itself. Here we are introducing a novel method to overcome its toxicity and make it more deadly to the viruses. We have designed a catalytic disinfection system that you see in the right picture that acts like the catalytic converter used in the exhaust system of the vehicles that you are familiar with. When the recirculating air containing the viruses and ozone enter the catalytic disinfection system, they pass through a foam-like catalyst structure that breaks ozone to some smaller species called active oxygens. These oxygen species can kill any viruses, bacteria, and fungi in just a couple of seconds. And as a bonus, it can also help eliminate most of the other pollutants in the air. The novel catalytic disinfection system, which is highly durable and cost efficient, can provide the residents with a high quality fresh air that is also free of pathogens and any other viruses, even they may emerge in the future, and also not leave any footprints of the toxic ozone in the air. Thank you.
Thank you very much. Can Zongru Lee turn on your camera, please? Clock froze or some kind, but I'll check on that. Yeah, it froze, so I don't know how long. Are you ready?
Yeah, I'm ready.
Okay, you can start.
So, hello everyone. So today I'm going to talk about some design using the space. So if you are familiar with digital signal, you should know that in the computer or microprocessor, the data is transmitted in binary numbers. For example, 101010. But in the space, it's a radiation environment. It has plenty of radiation particles, like neutrons, protons, heavy ions. And when these particles hit our computer, it can flip the data, like it can make 1 to 0 or make 0 to 1. And this is called the single event upside. This would be a big problem for the space applications. And another concept I have to talk about is flip-flop. Some of you may hear about it, but it's not shoes on your feet. Flip-flop is a fundamental building block of digital electronic systems used in computers, communications, and many other types of systems. It's a basic element of the sequential logic and is used for the data storage. And the flip-flop is made up of latch. However, latch and flip-flop are sensitive under radiation. So as you can see, the picture at the bottom is the schematic of the latch design. And on the left side is a conventional design. And the one on the right is our radiation hardened version. So you can see the difference is instead of using the single pair of transistors, we use the double. The reason is that, for example, in the conventional design, when MP1 gets hit by the radiation particle, the data will get flipped. But in our design, only when both MP1 and MP2 get hit at the same time, the data will be flipped. So this would reduce the probability and then reduce the error. And actually it does. We designed a microchip with 10,000 flip-flop connected in series. And we went to the United States last year and did a radiation experiment. We used the radiation particle to hit the chip and to see how many errors we would have. And the results show that the stacked transistor design has around 17 times improvement over the conventional D flip-flop design. Also, when we draw the layout, we can also implement some other techniques, such as interleaving, chat sharing, and we can get even better performance. So in this case, this design could be a good option for the designers to use in the space applications. Thank you.
Thank you very much. Next presenter is Behzad Hassashanhi. Can you turn on your camera, please? Be ready.
Hello, everyone. Can you hear me?
First is going to be Reza Khatib Zadeh Davani. Sorry. Reza, are you ready?
Hello, yes.
You can start.
Okay. Good afternoon, everyone. My name is Reza. I'm in third year of PhD program in mechanical engineering. My thesis is about the development of pipeline properties. Pipeline steel properties are low temperature application. As you know, pipeline steels are long distance pipes that are used to transport the fluids from the source to the market. There are more than 840,000 kilometers across the country, and they cost more than $20 billion per year, including repayment, maintenance, or exchange. There are some fluids in the pipeline steels that are hazardous and corrosive, such as hydrogen sulfide, which is a strong acid. And there are some hydrogen atoms in these chemicals that can attack the pipeline steels. They create the blisters and cracks, as you see on the left side of the slide. They are so beautiful, but they are harmful for the mechanical properties of pipeline steel. Also, low temperature environment can affect the mechanical properties, and they cause the rupture or brittle fracture, as you see in the picture. Hopefully you survive in Saskatoon at -40 or -60 degree of Celsius, but sometimes pipelines cannot. So my job is to respond to this industry issue and solve it. On the right side, this is me after a long time hard working on the pipeline steels. You see my hair is white at that time, but not right now. One solution is that I can add vanadium and niobium to improve the mechanical properties. I can change the chemical composition by adding niobium and vanadium, as you see, and I can improve the mechanical properties of pipeline steels. Moreover, after that, we can use the rolling machine. We should change the thickness of the pipeline steels to the standard size. So we use the rolling machine, but the temperature is too high. It's about 800 or 900 degree of Celsius. So we should use the cooling system to reduce the temperature to the room temperature. So there are some parameters in rolling and cooling system that we can change the mechanical properties of pipeline steel. And finally, I hope to improve the mechanical properties and also the fracture toughness of pipeline steels. Fracture toughness is a mechanical properties of pipeline steels that determine the fracture, the brittle fracture. So in this thesis, I could improve by these parameters. And thank you for your attention.
Thank you, Reza. While the judges deliberate, can Behzad be ready, please?
Hi, can you hear me?
Give us 1 more minute till the judges put their qualifications. Thank you.
Sure.
Okay, next participant is Behzad Hassan Shahi. Are you ready?
Okay. Yes. Soft robots are inspired by nature, where creatures with soft bodies and no hard skeletons have affected robotics design. And a new era of robotics in terms of embodiment artificial intelligence has been started. Soft robots have many applications to work with sensitive and fragile environments. For example, a robotics arm to pick and hold the live organs or sorting the fruits. Designing a soft body system with a large range of deformation is challenging in soft robotics. Currently, soft robots have been designed and built based on bio-inspired methods. Because of that, the available soft robots look like animals, like worms, jellyfish, or octopus. So it raised a question in my mind that, is it possible to design a soft robot which is not like animals? Topology optimization is a standard design method to design rigid body systems. It allows designers to create a system without having any previous idea regarding the final shape and geometry of their design. Topology optimization is a black box design method that works based on the mathematical model of the system. It starts with the design domain and the boundary condition. Topology optimization discretes the design domain into finite elements. Imagine that we want to use the small pieces of Legos to cover our design domain. After setting up the optimization requirements such as objective functions, constraints, and design variables, topology optimization remove one block from the design domain and jump into the mathematical model to analyze the remaining design. If the results satisfy the constraints, topology optimization returns and remove another block. It is possible that the results do not satisfy the constraints. Then topology optimization will keep the removed block. It's like a Jenga game that players try to remove blocks without making the tower fall. It is the process of removing and keeping will continue till satisfying the algorithm's stop criteria. Finally, topology optimization will provide a design layout that satisfies the design requirements. In my research, I hope to modify topology optimization based on a soft body system to design a soft robot which is not like an animal. Thank you so much.
Thank you, Vishad.
My pleasure.
Next participant is Ninu Kalingal Mohandas. Can you be ready, please?
Sure. Okay, can you hear me?
Yes, we can hear you properly. Just give us 30 more seconds, please.
Okay, sure.
Thank you. Are you ready?
Yeah.
Okay, you can start.
Good afternoon, everyone. As you all are aware, the world population is increasing. Along with this growing global population, the demand for food proteins is also increasing. The current major protein sources are animal-based ones. Based on different studies, these animal-based proteins produce higher levels of greenhouse gas emissions. Also, the increasing protein demand would necessitate the more production of feed proteins for animal protein production. Approximately 5 kilograms of plant proteins are required as a feed to produce a kilogram of animal protein. Considering this, in order to cover the increasing protein demand by staying within the planetary boundaries, there is a need for sustainable production of existing sources of protein as well as development of new protein sources for human consumption. The right-hand side of my slide shows one such alternative protein source available to us in large quantities. Canola must be known to most of us. They are the second largely produced oil seeds in the world. These canola seeds are not just only sources of oil, but they are great sources of proteins as well. Currently, As a protein source, they find wide applications in the animal feed market. Through technology, if we could convert these canola proteins directly suitable for human consumption, we are creating a new protein source to meet the increased human demand. Here, we are not trying to eliminate the existing animal protein sources, but finding a more stable and sustainable alternative. Even the United Nations recommends we need to keep a balance between the protein intake from both plant and animal sources. The Canadian Food Guide made revisions to incorporate plant proteins. Also, by doing this, we are creating more revenue opportunities to the local farmers who produce these canola seeds. In my research, I'm trying to find out what are those technical and economical challenges in front of us in commercializing these canola proteins. By finding those challenges, analyzing them and solving them to make sure that these new proteins are available to us as a sustainable protein source so that we all can eat healthy, live healthy with reducing the stress on our environment. Thank you.
Inu, thank you. Ayman Siddiqui is the next participant. Can you turn on your camera? We'll just give one more minute to the judges to deliberate. Ayman, are you ready?
Yeah.
You can start.
Hello, everyone. As we know, that internet has become an essential part of our life. We can get connected with internet with each other. A term Internet of Things is used to describe a system which consists of many devices that communicate over the internet. There are several applications of Internet of Things or IoT. There are a lot of applications we see IoT around us. For example, smart wearable health monitoring devices, home security system, and more. There are also other applications of IoT or Internet of Things which are still in a phase of development, such as automated cars, remote patient examination, and remote surgery. These future IoT applications will be based on huge network of sensors. The sensors in these IoT networks will exchange the information using the RF or the radio frequency signal. They will exchange the information wirelessly using the radio frequency signal. The RF signal, when it passes through the environment, it gets distorted. And when the RF signal gets distorted, so it means the information that was sent becomes unreliable. The future applications such as the automated cars, remote patient examination, and remote surgery need to meet the requirements of ultra reliability and low latency. What does that mean? Imagine that there are automated cars running on a road, and suddenly a pedestrian comes in front of the automated car. So the automated car has to detect the pedestrian reliably without confusing it with other minor hurdle and apply the brakes with very low latency, otherwise it can cause the accident. So following the ultra reliable and low latency requirements becomes more and more important in the future smart applications. Further, future smart IT applications need to follow some new standards. For example, the information transmission in the future IT applications will take place by the RF signal using the short data packets as compared to the long data packets. What does it mean about short data packets? Short data packets can be assumed as the small packets carrying the data. The short data packet-based communication is still in the phase of development. One of the problems in implying short data packets is that how we will counter the effect of the environment and reliably detect the information that was sent without causing the extra latency. So my research has the potential to eliminate the negative effect or the distortion caused by the environment and reliably detect the information that was sent. So with low latency. So my research will contribute towards solving this problem and will enable the future smart application like remote surgery. Thank you.
Thank you, Ayman. Next participant is Shiva Mustafavi. If you could get ready, please.
Hi, can you hear me?
Yes, we can hear you. Just give us 30 more seconds, please.
For sure.
Thank you. Shiva, are you ready?
Yep.
You can start.
Okay. So, hi everyone. We all have seen old people with amazing and daring stories from their youth. For example, for me, it's hard to believe that my grandfather used to walk 15 kilometers daily from home to work, as I see that how much trouble he's going through these days just to walk in his backyard to get fresh air because of the bad backs and the painful knee, which are unfortunately really common in old people. You know, they usually suffer from osteoarthritis, which is a common disease, especially in the knee joint, that can cause inflammation and pain, and it can affect 10 to 15% of adults. Despite the fact that osteoarthritis is common, there's still no cure for it, and our best defense is to prevent it or detect it in early stages to prevent the development of the disease. So, knee is made up of bones and soft tissues like meniscus and cartilage. Meniscus is a tissue between the femur and the tibia, which are the two bones in the knee, and its important role is to distribute the load within the joint. So as you can see that without the meniscus in the left bottom images, that without the meniscus, the contact stress increases significantly, which can cause cartilage damage and injury to the knee, which can increases the risk of the osteoarthritis. So we should prevent the meniscal injury. Studies show that activities that require high knee flexion, like squatting or kneeling, can cause meniscal injury. So in this study, we're trying to find out how meniscus responds to the load and flexion. For this purpose, we're using magnetic resonance imaging technique, or MRI, to get high quality images from inside the knee joint to compare the meniscus shape between unloaded and the loaded knee. So you can see that in the top right images, the red regions are the meniscus, and we can see the changes from unloaded to the loaded position. We also use quantitative magnetic resonance imaging technique, which can give us more information than just the morphological images to study the changes in meniscus from unloaded to the loaded position. So we can see the QMRI parameters for the meniscus in the right bottom images. So our results so far show that in healthy individuals, the QMRI parameters are significantly different between unloaded and the loaded knee meniscus. So the next step is to compare the changes in the meniscus from unloaded to the loaded position between the healthy individuals and the osteoarthritis patients to create a biomarker to detect the osteoarthritis in earlier stages. So we're trying to find out how meniscus behave under the load to prevent the injury and then create a biomarker to detect osteoarthritis in earlier stages. Thank you.
Thank you, Shiva. Next participant is Amir Payan. If you can start getting ready, please. Mir, are you ready?
Yep.
You can start.
Hello, everyone. Today, I'm going to talk about the air, the most essential thing that we need for our lives. Without food, we can survive for a couple of weeks. Without water, we can survive for a couple of days, but just few minutes without air. But what about the quality of air? Let me ask you a question. Have you ever noticed the strange smell when you open a bottle of nail polish remover or a bottle of detergent? Did you ever notice the strange smell when you start painting a wall? What about the smell of a new car or new house? Did you? I bet most of you did. These are all chemical solvents that are emitted to our homes from furniture, from carpets, from walls. Indeed, we are all surrounded by these chemical solvents. Just for 1 minute, think about your daily routine during the pandemic, during the COVID-19 pandemic. We all are experienced the working from home. And to be honest, working from home is going to be an inseparable part of people's lives. So we are facing the situation that people spend all their lives in home when they are surrounded by dangerous chemical solvent. And believe me, it's going to be a real health problem since around 3.3 million deaths each year caused by indoor air pollutants. And Canada ranked second highest in emission of these dangerous chemical solvents. Around more than 2,000 kilotons of these chemical solvent are releasing to our home each year. And this is the place that my thesis is gonna address it. It seems that we are in real war against indoor air pollutant in our homes, and my thesis is gonna work on removal of indoor air pollutant by using photocatalytic method.
The photocatalytic method basically means trapping the indoor air pollutant and then attack to this indoor air pollutant from air and from the ground. The photo part means attacking to the air pollutant from air, and the catalytic part means attacking to the air pollutant from the ground. Compared to the 10 years ago, the result of research like my thesis caused reduction about 15% in emission of indoor air pollutant, and we keep doing this. Thank you.
Thank you, Amir. The next participant is Sayed Shahim Vedae. If you can get ready, please. It seems that there's a lot of noise in the back of the room in here, so if you can please lower your volume so the judges can hear clearly. Thank you. Shahim, are you ready?
Yes, I'm ready.
You can start.
Hello, everyone. She's Linda. Hi, Linda. But she doesn't feel really good these days because she feels pain in her stomach. So she went to a doctor, and doctor, after examination, asked for endoscopy. She said, hell no, I'm not gonna go for that. For those who are not familiar with the endoscopy is a tubular device which will enter to the esophagus from the mouth. And trust me, it's really painful. But hopefully there's a second option for Linda, capsule endoscopy. Capsule endoscopy is a capsule-sized device which has a camera, lighting system, batteries, and transceiver unit. So in this case, when Linda swallowed the capsule take pictures and send the data outside of the body into a data logger. And after that, doctor can analyze these images. Doctor, after looking at these images, he found that there is something wrong in there. Yes, this is cancer cell. So he booked an operation room and asked Linda for a surgery. During the surgery, doctor said, wait a minute, I don't know where should I operate on. I have some pictures that show the cancers, but these images doesn't show any information about the location. So hopefully this is where my thesis come to the work. I have proposed we will add a small magnet into a capsule and a sensor belt wrapped around the patient's body. When the capsule swallowed into a body, the magnetic field will be captured using the sensor belt. And we have a global position of the capsule. In addition to that, in order to increase the accuracy, we will add 4 tiny cameras at the side of the capsule. In that case, when the capsule goes to the body, it will look at the GI's wall and it can detect all tiny motions as small as 1 millimeter. So in that case, when the front camera takes the pictures, the capsule tagged all these frames by their location. And after that, it will send them to a doctor. So in this case, when doctor is going to go for a surgery, he knows where he should operate on. In addition to that, when we have a drug delivery capsule, the capsule can go to the body, goes to the correct location of the cancer using the localization method that we have proposed, and then release the drug at the correct and exact position. So in that case, even the surgery needs would be eliminated. And this is my research topic. Thank you very much.
Thank you, Shahim. Next participant is Arash Faradel. If you can start getting ready, please.
Can you hear me?
Yes, yes, we can hear you. Give
Great.
us just 20 more seconds, please.
Yeah, sure.
Thank you. Okay, Arash, are you ready?
Yeah.
You can start.
Hello, everyone. Do you remember the wildfire of last summer? In that time, I was thinking that why can't we still control wildfires? And that was the starting point of my project. Before taking a look at the solution, let's first see some statistics. In 2019, only in Canada, more than 1.5 million hectares of forest and land burned, which is 15 times more than the area of Saskatoon. That's a huge number. But why should we really care about this? I'm sure that everyone knows that forests play a vital role in our environments. So now let's take a look at my solution. The first and most important part is the detection. So we should detect the fire as soon as we can detect it. So there are two main ways that we can detect the fire. The first one is the satellite, and the second one is airplane. But satellites cannot detect small fires, and the airplanes also are so much expensive. So we will choose the third one, which is the drones. In the conventional methods, the drones send an image like a camera to a server, and then in the server, it detects the fire. But that's not favorable because we would like to have less data transmission by sending less images and having less power consumption. And finally, we will have a longer flight duration. So we will use onboard processing, in which we can do everything right on the board, and we don't send any data to a server. But when we detect the fire, for the case of validation, we will send a couple of images to the server. And if the server confirms, we will start the surveillance phase. So the surveillance phase is for starting a live feed of the scene. That is critical because we want to have a visual on the scene. Again, here, we will take a look at our golden rule. We want to have less data transmission in this phase as well. So instead of sending all colored images, we will start sending some grayscale images, like 20 grayscale images in a group with only one colored image. And then using our AI algorithm, we start painting these grayscale images. So the grayscale images have lower sizes, and we are saving some data and we don't send them, which results in longer flight duration. And we will have a complete surveillance video. So we propose two novelties, the onboard processing and also our novel method for data transmission. And finally, we can have longer flight duration and cover a wider area. So thank you, everyone.
Thank you, Arash. Our last participant of today is Muhammad Mahid Abedi. If you can start getting ready, please. Mahid, are you ready?
Yes, I do.
You can start now.
Hello, everybody. My name is Majid, and today I want to talk about evaluating subjective road safety using crowdsourced or social media data, which is in the field of road and transportation safety. So let me start talking. With the importance of the subject. More than 1,700 fatalities, almost 9,000 serious injuries, and more than 300,000 accidents in Canada as a developed country only in 2019 is a catastrophe. So it's my responsibility as a transportation engineer to do something with this problem. But if I want to go through the traditional approach, I have to use objective safety, which is using collision data. It means that I have to wait for accidents to happen, then decide about the level of safety for a region. That doesn't make sense for anybody. It's exactly like a doctor who is waiting for his patient to be died, then decide about his diet. What I'm going to do instead is using people perception or subjective safety as a surrogate safety measure to measure the safety level for a region. But you may wondering, how can I measure people perception and what is the source of data? The answer is crowdsourcing. Actually, crowdsourcing is the collection of information and opinion from a group of people who upload their data through the internet, social media, and smartphone apps. After reviewing different platforms, I've selected Twitter as the best platform for my purpose. What I'm doing is extracting the tweets for a specific region, then separating the road safety related tweets and classify them based on different classifiers, for example, based on the transportation mode, driving, walking, and so on. Then I'll label every tweet based on the sentiment of its context. If the tweet is talking in a negative way, neutral, or positive one. And the final step is developing a model to find the link and connection of the extracted and classified tweets and frequency and severity of accident. So using this model as a surrogate safety measure, we don't have to wait anymore for accidents to happen, then decide about the level of safety for a neighborhood. We can easily use this model to predict the accidents and to predict the level of safety for every region in our city. Thank you very much.
Thank you, Majid. So this is how we wrap up with the online presentations. For now, let's give our judges some time, some minutes to deliberate. We, as an audience, we have to select 3 participants. We ended, for the persons who are here in the auditorium, there's a survey that we handed in paper. Please choose 3 participants within the in-person and online. There should not be any difference between them. And for the ones who are assisting online, there's a Zoom survey that's going to pop out for you. So let's give the judges some minutes, and we'll be back in 5 to 7 minutes. Okay, okay, perfect. We'll let you know once we need to. Yeah. Hi, everyone. So in order to continue with the schedule and while the judges are deliberating, I would like to ask Dr. Jafar Sultan, Associate Dean, to give us a message, please.
Okay, do we have done? Okay, great. Okay, good afternoon. As Associate Dean, Graduate Studies and Strategic Projects of the college, it is my pleasure to provide a few words as a closing remarks to this wonderful event, the Engineering 3-Minute Thesis competition today. Personally, to me, this is an exciting event because after the COVID-19 situation, this is one of the early student activities that I could participate, and I am very happy about it. This was a success, really, really a great job. Before winners are announced, I would like to offer my congratulations to all the students who participated in the competition today. This was a great achievement. The fact that you could share your work results of wonderful research that takes months and years in 3 minutes with the audience, that was a new dimension in your communication skills, and you all did a wonderful job. This was a wonderful opportunity to share your research and develop your communication skills. Not only that, but also this was a good chance to build networks with your fellow students and our community. And personally, I see this as a good gauge of your deep understanding of your research. If you can explain your work in everyday language to a general audience, that is a very good sign that you know your job very well. Students, faculty, alumni, and industry partners all came together for today's event. These collaborative relationships allow us to expand our impact, knowledge, and collaborative innovation beyond what any of us could do by working alone. For the audience that watched the whole event remotely, I hope you enjoyed this event. This was a sample of the great research that our students do in their labs, and the fact that they could provide a good starting point for a hybrid presentation. Again, this was a new experience, and they did it very well. Now, important thing is to pay attention to the fact that the research that is presented in 3 minutes is usually the result of months and years of hard work in the lab, long hours, and the work and analysis that students do in their research group. Our college cares deeply about the success of our students, and we are very proud of their achievement today. Now, the organizers of this event, I would like to extend my thanks to everyone who contributed to the Engineering 3-Minute Thesis event. Thank you to the judges, the sponsors who offered their support in making this event possible. I would like to ask you to give them all a round of applause. And a special thanks goes to the Engineering Graduate Community Council, who have been working hard for the past few months to bring this event to you. I know that all the planning with the uncertainties that COVID brought up was a task, and they were following the news and following the latest development to make this event happen in the best possible way, and they did a wonderful job. So please give them Another round of applause to the EGCC members. I hope you all enjoyed the competition today and encourage all students to join the EGCC in their future events. I know that they are planning an engineering graduate research conference this fall. Please make sure that you participate actively, submit your works, and attend their event. And I know that the judges are still working on the outcome of this competition. Regardless of the results, I know that we all are winners in this competition because we learned as audience and we practiced our presentation skills, our communication skills as participants. So really a good job that the EGCC and the participants did. And I will wait for the outcome of the deliberations of the judges. And I would like to offer my congratulations to the winners and a deep thank you to all that participated, remotely or in person. Thank you very much.
Sorry. Thank you, Dr. Sultan. So now it is my pleasure to introduce Rosanna Santos from SAS Power. She's online and she has a message for us.
Thank you. Can you hear me okay?
Yes, we can hear you.
Okay, excellent. Good afternoon, everyone. Thank you so much for having me. It's very, very exciting to be here. And I agree with Dr. Sultan. I commend you all for your efforts and using your creative minds to make the world a better place. I think that the presentations really speak volumes to that. As I'm here to represent Sask Power, I'd like to start with talking about the electric grid. It's quoted by Black & Veatch as one of the world's most powerful machines. In one of their articles, they state that the origins of the electric grid date back to the Pearl Street station in New York City, which served 59 customers when it started in 1882, to today in the United States alone, almost 8,000 power plants, which is connected by nearly 3 million miles of power lines. At SAS Power, we have 157,000 kilometers of power lines, and we serve 545,000 customers. Our electric grid is an engineering marvel that has been the backbone of societal development for generations, and it is the result of one man, Thomas Edison. Thomas Edison is one of the greatest inventors of all time. He has been the epitome of resilience. Why? When we think of his many inventions beyond the electric grid, we often think of the light bulb. He tried numerous ways to make this work, 1,000 ways. He said, I didn't fail 1,000 times. The light bulb was an invention with 1,000 steps. Over the last 2 years alone, all around the world, we have had to learn and live with resiliency. COVID has challenged our global community in numerous and astounding ways. And I appreciate the welcome message from Dean Suzanne Cresta, where she states, we are living in a remarkable time of creativity, resilience, and rapid response. And she used the word resilience. What does the word resilience even mean? It's defined as the capacity to recover quickly from difficulties. It's a toughness. It's the ability of a substance or object to spring back into shape. Elasticity. As I think about the meaning of this word, I think back to my own time going through engineering in university and how I needed to apply resilience to get through school. I remember my first day in a big amphitheater with hundreds of people, and they warned us of how challenging it would be. And they were right. It took many moments of perseverance and tenacity to keep focused on the goal, and much blood, sweat, and tears. Later, in my first year of university, a guy I didn't know saw me walking through the cafeteria and thought my big engineering and physics textbooks I was carrying had to have been my boyfriend's and not mine. After I met him, he later told me that, and I was very offended. And he applied resilience to win my heart and is today now my husband. Kidding aside, I want you to be proud of where you are today and what you have achieved. Know that you are already resilient to be here in this moment. In closing, Thomas Edison famously said, "Many of life's failures are people who did not realize how close they were to success when they gave up." The most certain way to succeed is always to try just one more time. I will leave you with this question. How can you inspire others to be resilient as well? Thank you.
Thank you, Rose, for your kind message. So we're going to have a few more minutes to wait for the results from the judges. Just keep tight.
Hello.
How are you doing? Good.
Yeah, he muted. Thank you. So before we give the results of this competition, Dr. Tate Tao is here to introduce to us the Sigma program. So thank you, Dr. Tao.
Hey, hello everyone. Could you hear me okay?
Perfect. So thank you for everyone doing your presentation today. I was one of the judges and thoroughly impressed with your presentation skills and the willingness you are working on different projects. What I'm doing here is to introduce a potential opportunity for some of you want to take your research projects one step further. So this is a program called Sigma program. It's Saskatchewan Innovation Growth and Market Acceleration. So I'm a faculty member in this college in the Ranjin Graham School of Professional Development. My role is also the laboratory in engineering entrepreneurship. So in our school and my role is we actually provide professional development trainings. So that's complementary to your technical training after you graduate, considering about the job opportunities and commercialization. We see a lot of really good technology today. And a lot of that is really what I consider as invention. It's important. I see a lot of that will make really positive impacts in the society if we can implement them. But there is a gap between what you do in the lab as invention to actually being commercialized and actually used in people's life, right? We recognize that that part of gap is what we call commercialization, and we find it either entrepreneurship or actually partnering with a larger organization is needed. So the program of Sigma is really to do so and allowing us to help building teams to do that. You know there are a lot of commercialization opportunities outside, but most of them focusing on building a company. So basically, once you got into those programs, you're actually being pushed very hard to starting to make a profitable business and potentially taking on investment funding and providing that return, right? One of the things most people don't realize is actually once you take a venture capitalist funding, the expected return is 45% per annum. You heard that right, 45% per year. That's the return typically investors are expecting from startup companies. That become really big challenge. So instead of actually focusing on making students building companies, we're focusing on building the leaders, building you and your skills, because that's, as a university, that's what we believe our role is, to focusing on the people. See if I can change to the slide. Okay, so you have the question like, what is Sigma? Sigma is what I call the educational entrepreneurial accelerator. It runs from May to August. The official start date will be May 16th. It will offer you a rigorous process to learn about how to launch a new innovation-driven technological venture, which a lot of your technology will be in that process. We provide mentorship. We provide a community, so you're not doing this alone. You're not thinking, why am I doing this? Starting a company, you will be surrounded with your fellow graduate students and undergrads who have similar passion pushing you on, and we provide a bit of funding to work on that as well. Can you go to the next slide? So if you're interested to find out more, this is my call for action for you. If you're interested in finding out more, go to our website, which is the first QR code, or go to our college website, find Sigma and the department. Learn more about it. Like there are more information on the webpage. We basically provide about $2,000 per month per person for you to build your own company in a team. And we don't take any equity, and because we're a university, we provide all of that training for free. But because the funding, you can imagine, it's very popular. It's not going to be a very easy session to get in. And I won't take too much of your time today. What I want you to do, the next thing is go to our website, learn more about it. And if you decide you're interested, come to our information session on March 15th. It's in the evening. It's about 2 hours. We'll explain to you what the program really is in detail, how you can get ready for it, and how you can build a team to really get into it. And even if you think you're not ready this year or now, most of you are here for a couple more years of your study. That's okay. We have a lot of activities, workshops, and courses that you can take to prepare yourself for next summer. So that's my call for action for you. Please do come out and join us. Most of the events, like the information session, will be have in-person and online option for you. So pick what works well for you. We look forward to see you there. Okay, thank you for your time.
So just about like 1 or 2 minutes while they bring the results back from upstairs. If you can come to give your experience for the Sigma program, please.
Hello everyone. It's a great opportunity for me to take this time to share my experience with Sigma program. Actually, we joined Sigma last year, and it was a really good platform for us as graduate students because, as you know, we are engineers, so it's easy for us to find a solution for any problem. So it takes time, but it's not impossible for us to find a solution for any problem in the industry. But the way we present this solution and the way we commercialize this solution is something that we are lacking knowledge and our weakness point. So in the Sigma program, I got really good mentorship and how to do this commercialization and how to change your idea into a practical solution for the industry and how to present your idea. And so, like as Tate mentioned, you are joining a big community of innovators, like the ones that had successful experience with building up their own business and the ones who failed. So you are getting in touch with a bunch of experience that could help you to change your idea into a successful business, because ultimately we are engineers and we should be the persons who solve the problem. So so you should not be limited into your labs. So you should come out and join these kind of programs to take the mentorship and workshops and lots of materials that are provided in Sigma program to know how to marketize your idea, how to sell your idea. That's the missing link I think we have between research and industry. So yeah, I really encourage you to participate these info sessions because I'm sure that you will benefit from it. Even if you don't join the Sigma program this year, but it gives you an idea of what's happening and what could you do in the future. Thank you for the opportunity.
the time has come to know our winners of the competition today. If Dr. Sultan can please join us in the stage to give the certificates. First, EGCC would like to recognize and present our judges, and we have a small certificate for them. So, Dr. Tate Kao, if you can come here, please. Christy Mueller.
Really great job.
Yeah, thank you. Dr. Souza Pap. Dr. Sumit Kahanda. Dr. Mozen Shakuri. And Margaret Kuzik, please. Thanks to the judges for their insight and their time to come. Okay. So now it's time for the prizes. As audience choice, ready? We have Priyanka Tirumareri, please. Congratulations. As fifth place, we have Arash Faradel, which I believe he's online. So if Arash, if you can turn off your camera and microphone. Oh, he's here. Okay, hi. So in fourth place, we have Tumpa Sarker, please. Congratulations. Okay. In third place, we have Sayed Shahim Vedae, which I think he's online. Yeah, so, Shahim, if you can turn on your camera, please.
Hi, everyone.
Congratulations.
Thank you very much.
Do you see your certificate? Should I get closer?
Yeah, that's perfect.
It has your name. We can testify that. Congratulations.
Thank you very much.
So in second place, we have Shahav Minae, please. Congratulations. And finally, in first place, we have Christopher Elash. I think he left. So.
I'm just online for the online session here, but wow, thank you very much here.
Congratulations.
Thank you.
So congratulations to all participants and winners. And as a thank you for everyone for your assistance here in person, EGCC has prepared a swag bag and a take-out lunch for everyone. It will be right at the exit. You want to give your message?
Thank you, Dr. Sultan, for joining us for the Winners Award. So thank you again for your participation in the 3-minute thesis competition this year. Thank you all for your coming. And also I would like to share my thanks to our sponsors, SASC Power, Engineering Advancement Trust, and College of Engineering, and Saskatoon Engineering Society, and also the Graduate Society Association. Thank you, everyone. I hope to see you for the next event, Engineering Graduate Research Seminar in September. Please join us in September. You will receive the information about that event later. Thank you very much. I hope you have a great day and also the weekend. Back to you.
Thank you, everyone, for your time and your patience. I wish you all a good weekend. Thank you.